Now, as we have studied, what if there is one train, one person, if person is moving, whether it is in same direction or opposite direction. So the same thing we'll learn about two trains. What if two trains are there? Now instead of train, if they have given car, the things will be same. So I'll write, if two trains are passing each other, two trains are passing each other. So the train number 1, that is T1, and train number 2, I'll write TR2 and TR1. So if this train is not moving, if train 1 is not moving, I'll write not moving, but only train 1, and train 2 is moving in this direction, then the time will be equal to, as we know, time equals to distance upon speed. So time will be equal to, this will be, the train will be, if the train is in this direction, we will count only the length of train. Why? Because this train is over here and this train is moving into that direction. There is no relation between this train 1 and train 2. Now, if instead of this direction, the train 2 is moving into this direction where train 1 is already there. So, the distance will be equal to L1 plus L2 divided by S1. Why L1 plus L2? Because L1 is length of train 1 and L2 is length of train 2. Now we cannot ignore the length of train 1. In one person and one train, what we were doing? We were ignoring the length of person. But here, the length of the train will be definitely something greater to the length of person. So, train 1 and train 2. If train 2 is passing train 1, so if suppose say this is train 1 and this is train 2, so if the train 2 is moving into this direction, so the speed or the time will start when the train 2 is over here and when it crosses whole the train to this point. So what we'll take? The distance will be L1 plus L2 divided by S1. Why S1 only? Or I'll write S2 because we are talking about train 2. For train 2, this will be T1, S1 and D1 or L1 because we are taking length. Same for this will be 2. Because we are talking about train 2. Train 1, this will be T1, S1, L2, L1 or D1. Now train 2 is moving. Train 1 is not moving. Train 2 is moving. So of course, the speed will be S2. Same way, what if both train are moving? Suppose say TR1 and TR2, that is train 2 or train 1. Both are moving and in opposite direction. They both are moving in an opposite direction. Now we know when there is opposite direction or different direction, what we have to do? The length will be, just make sure that whenever there is train or car or a bridge, we will count the length, that is L1 plus L2. Why? Because we cannot ignore the length of train, car or bridge. There is greater. But instead of that, if signal is given or if the person is given, then what we can do? We can ignore the length of person or signal. So, this will be T equals to L1 plus L2, that is length of train 1 plus length of train 2. Divide by, now over here only train 2 was moving. So we have written S2. But both the trains are moving but in opposite direction. So the speed will be, we have studied this in train and person. What it was? Yes, the speed will be added. So that will be S1 plus S2. Correct? The thing is same. They both are in opposite direction because they both are moving. It will be S1 plus S2. But the main thing is opposite direction. Now, what if the trains are going into the or moving into the same direction? The third case will be, this is our first case, second case and third case. What if the train are moving into the same direction, whether into this direction or this direction, but they will be in same direction, they will be moving in same direction. So I'll write same direction. Now, as I told you before, the t will be equal to, length will be or distance will be, because there are two trains, it will be L1 plus L2. So L1 plus L2, that is length of train 1 and length of train 2. Divide by, now over here it is same direction. So what we will write? The speed will be subtracted. So S1 minus S2. Over here, the condition is S1 greater than S2. If S2 is greater than S1, then we will write S2 minus S1. So these are the three main points and the other three we have studied before. Now if man and, now we will revise it quickly. Now what if man and signal and the train is there? What we will do? We will just take length of the train. Why? Because we can ignore the length of the person or signal. So it will be length of the train divided by speed of the man. Now if the signal is there, of course signal will be at its position. It won't be moving. Right? So the speed will be added. The speed will be speed of train only. Now what if there is a bridge? I'll write here. What if there is a bridge? Say this is the bridge and the train is passing that bridge. So T will be equal to L1 plus L2. Why L1 plus L2? There are no two trains, but the length of the bridge will be obviously greater than something. So L1 plus L2. Because we cannot ignore the length of the bridge, because of course the bridge won't be like of 2 meters or something. It will be greater than that. So we have to take the length of the bridge also. So L1 plus L2 divide by what? L1 plus L2 divide by S1, and that is the speed of train. Obviously bridge will be at its position, it won't be moving. So we'll take only speed of train. So these are the fundas. Now we'll see problems on train, exactly the problems. If you remember these things, it will be very easy for you to solve any problem related to this chapter. So just make sure that you note down all the points.